Hello everyone, in this video we will look at a shifted and compressed sinusoid. The equation is y equals 1/2 plus sine of 4 times x plus pi over 6. This is the kind of work that you need to show and understand in order to get maximum benefit from the class. And if all you do is basically plug into a calculator, then the individual that deserves a degree is the calculator and not you. So make sure that you're ready for the kind of rigorous analysis that you'll be facing in your future classes. Make sure that you follow the suggestions here. So if you remember, this is of the general form y equals a plus b sine of c times x minus d. We have previously explained what each of these letters stand for. A here is going to be your baseline, which is at 0.5, as you can see in the image here. B is the amplitude, which here, notice the coefficient B is just 1. So there we get from those two pieces of information, where the baseline is and where what the amplitude is, meaning how far above and how far below the baseline this graph goes, we can easily get the max y value to be 1/2 plus 1, and the minimum y value here is going to be 1/2 minus 1, which is negative 0.5. C, which we know is 2 pi over the period, in this particular example is 4. So if we set up a proportion, we get 2 pi over p equals 4 over 1. Cross multiplication gives us 4p equals 2 pi. Therefore, p equals 2 pi over 4 or pi over 2. D, which is the horizontal phase shift of this particular sinusoid, here notice it's given as plus, so if you write it in the form of a minus or subtraction, it becomes negative pi over 6. So the phase shift is negative pi over 6, and that's basically the starting point of one cycle of this sinusoid. So here we take the negative pi over 6, which is our starting point, and we add one period to it, which we found out to be pi over 2 here, and we end up with pi over 3 after some calculation, which means the end point of one cycle of this sinusoid is going to be at pi over 3. Now we can start at negative pi over 6 and take this period and find out what 1/4 of it is, and that means 1/4 of pi over 2, so it's going to be pi over 8. So we're going to add increments of pi over 8 to get these other three significant points. So we start at negative pi over 6, we add 1 pi over 8, we end up with negative pi over 24, another pi over 8 to that point, and we get pi over 12. And then do that again with pi over 12, we get 5 pi over 24. This one we already had, we didn't really need to do again, but I wanted you to see how you can actually get it by adding another pi over 8 to this point right here as well. So this calculation was unnecessary once you really understand what's going on. So we already had the ending point to be pi over 3. So now we have all the information we need. So we draw the center line, and we know that a standard sine curve is going to start at the baseline, then go to a max point, then to back to the baseline, then to a min point, and then back to the baseline. So, and of course the values here indicate that. So these are just the values we just found: negative pi over 6, pi over 24, negative pi over 24, and then pi over 12, 5 pi over 24, and pi over 3. Here's the baseline, y value 0.5, then the max 1.5, then back to the baseline 0.5, and then the min point negative 0.5, and then back to the baseline at 0.5. And just to sum it all up, notice that in this example, the standard sinusoid y equals sine x has been shifted to the left pi over 6 units because of this pi over 6 over here. And if you remember, when we're doing a horizontal shift, when it's x plus a positive number, that actually indicates a shift to the left. So that's consistent with our previous understanding of general transformations of functions. It's also been shifted up 1/2 unit. That's because of this 1/2. It has been horizontally compressed by a factor of 4, and that's where the 4 is, which caused that compression. And this is just to bring this particular problem in line with our general understanding of transformations of functions. I hope that helps out. Be safe till the next video.